Hey guys, Pike here. This is your endocrine system video number 3, covering the thyroid gland, parathyroid gland, and the adrenal glands, both the cortex and the medulla. So we're going to jump right in. The first gland we're going to look at today is the thyroid gland. The thyroid. The thyroid gland is a butterfly-shaped gland located in the anterior neck. So it's located in the front of your neck, over the trachea, anterior to your windpipe, to your trachea, and just below your larynx or your voice box. And it is the largest 100% gland in the body. Like, it has no other tissues. So it's the largest of the glands. It's composed of sacs called follicles that are similar to what we talked about with the ovaries. And they store a colloid, amber-colored, sticky material consisting of thyroglobulin, which will attach to iodine atoms. So all of our thyroid hormones are derived from a colloid. So really what we want to look at is that, okay, we're just please waiting. We want to look at the fact that they're iodine-based. Okay, so now looking down here at the picture, we have the thyroid gland, okay, is right here. It looks like a bow tie in the neck. And that's actually pointing to the middle of the bow tie. So y'all, it really looks like a bow tie that a man or woman would wear right where the thyroid would be. Okay, that's the shape of your thyroid. And it kind of hugs the trachea. The trachea is your windpipe, so that's the blue right there. The trachea is made of cartilage, so it has a little bit of give to it. Okay, and so you can see how it also relates to the major arteries around. There is the they've got a thyroid artery, you've got a common carotid that hugs either side of the thyroid, and then the major aorta that comes off of the heart. Okay, so the thyroid gland, we want to look at the hormones secreted here. The first hormone secreted by the thyroid gland is called thyroxine. And it is also called T4. And then you have another version. Sometimes you'll see it as just thyroid hormone, okay, because it is such a common hormone. But really, thyroxine is the technical name. But then another version of this is a very funky kind of spelling, okay, thyrine. Okay. Had to think for a second, make sure I got my thyrine. And this is T3 colloid. So really, I'm going to use the term thyroxine, or T4. So this actually targets all of your body cells. So it has a very broad function, and that is, it is increasing your metabolism. All of the chemical reactions, so this is increasing that metabolic rate. And when it does that, it causes heat production. So it's going to regulate all of your growth and development. So this goes right along with growth hormone. So this one regulates your growth and development. And this one is regulated by the thyroid stimulating hormone, or TSH, secreted by your anterior pituitary. So these two are similar. One bosses this one to be secreted. So here we have, obviously, if you have hypo or hyper secretion of this hormone, you will get either a low or a high metabolism. So what we want to look at first, okay, I do want to just mention that it takes TSH going to your thyroid to make your thyroid secrete thyroxine. Just to kind of show you, I know I just mentioned that, but the TSH from your anterior pituitary goes down to your thyroid and tells your thyroid to secrete thyroxine. So your metabolic rate is actually regulated by your anterior pituitary. All right, so one of the homeostatic imbalances, if you have a low functioning thyroid, meaning a hyposecretion of thyroxine, it is actually called hypothyroidism. Okay, but the technical term for that is called myxedema. Myxedema, or hypothyroidism. You have a low metabolic rate, you feel chilled, you have swelling, which is edema. Okay, edema is swelling in your body tissues. You are lethargic, or you just really feel really just tired, like extreme tiredness. Mental sluggishness, like everything seems to be going in a little bit slower pace. And if the myxedema results from a lack of iodine in your diet, the result is actually a goiter. A goiter is just an enlargement that protrudes from the thyroid gland on the neck. Okay? And so that is a goiter. So this happens a lot in third world countries where they don't have iodine in their diets. We have iodine in our salt. We eat iodized salt. So next, when you go home, or when you're already at home, look at your salt and see that if it is fortified with iodine. If it says iodized salt, it has iodine in it, so that we make sure we get enough iodine for this hormone, thyroxine. Now, the other extreme is called hyperthyroidism, and that has its own name, and that's called Graves' disease. So here, the thyroid gland is overstimulated. You have an elevated metabolic rate. They're sweating. Your heart rate is irregular because it's being overstimulated. There's nervousness and extreme weight loss. So sometimes it's really hard to gain weight when you have Graves' disease because your metabolism is greatly increased. And we will look at this also on the disorders Padlet. So this second hormone secreted by the thyroid gland doesn't have anything to do with your metabolism. It has to do with the calcium levels in your blood. So the second hormone secreted by the thyroid is called calcitonin, the calcitonin hormone. Calcitonin hormone is the reason why it is secreted is based on humoral stimulation. So your thyroid does not secrete calcitonin unless there is a changing blood level. Here we're talking about it's going to be in response to increasing blood calcium levels. Okay, but this hormone actually does not have a physiological role in humans. So it really doesn't affect our blood calcium levels as much as the opposite hormone that we're about to talk about in a second. But if you give it in a pharmacological dose, meaning a dose higher than what you normally find in the body, so given as like a prescription drug, it is used to treat diseases and osteoporosis because it helps to get that calcium into your bones. So really this doesn't really have a function in humans, but it is used as a prescription drug. It does target the skeleton, and it's going to inhibit our osteoclast. If you remember, those are our bone deteriorating cells or bone destroying cells. Those cells actually break down bone matrix to release calcium into the bloodstream. So it's kind of like going to your calcium bank in your bones, and they actually break into the bank, break into your bone matrix, and let out calcium into the bloodstream. Okay? And so that's calcitonin. So that's the two hormones secreted by the thyroid gland, thyroxine and calcitonin. Right? The next gland is actually on the back of the thyroid gland, and that is called the parathyroid glands. Parathyroid glands. There's actually 4 of them. There's 4 tiny kind of yellowish brownish glands on the back of the thyroid. And so really, y'all, it looks like just a bow tie that you have 4 polka dots on, like a polka dot bow tie. But they're on the back, and you can see this picture is the posterior view of the other picture from above of the thyroid. So you see those 4 yellowish brownish polka dots. Okay. And the only hormone here secreted by the thyroid, the parathyroid gland, is actually really easy because it's named after the gland. So this hormone is the parathyroid hormone. So really easy to know that these two go together. Parathyroid hormone, or PTH. The parathyroid hormone also has to do with calcium levels, but here we're talking about the other extreme. Okay, we're talking about decreased blood calcium. Okay? So here, this one is the most important hormone. So that's important. Like, this is the hormone that's important for our blood calcium levels. the most important one that regulates our calcium levels. So it is under humoral stimulation. Remember, humors are our fluids. So this hormone is only secreted in response to decreasing blood calcium levels. And we know that calcium is extremely important. Calcium is essential for the transmission of nerve impulses, for muscle contraction, and blood clotting. So very important to have our homeostatic levels of blood calcium. So here, if you don't have enough calcium, what would the target be? Where would you go find calcium in the body? Well, we know that our bone matrix stores calcium. That's where you find calcium salts. That's what gives bone matrix its hard structure. Okay? And so you go to your skeleton. So you target the skeleton, you target your kidneys and intestines, two places you can find calcium from your diet. So we have three functions because you're going to get calcium from each one of these in three different ways. So the function for the skeleton is we're going to stimulate those osteoclasts to digest that bone matrix. Okay? And so up here we talked about, right here, we're going to tell them not to. Like we're going to tell them not to break into the bone. We're going to inhibit them. But down here we want to break in and steal, not really steal, but to break down that bone matrix. So these osteoclasts will digest bone matrix and release calcium into the bloodstream. I don't really need to be highlighting all this, but because I haven't been highlighting functions on each one. But just to know that that is how that calcium gets into the bloodstream. Osteoclasts break down bone matrix, so it's kind of like going to the ATM for calcium. And your ATM for calcium is in your skeleton, in your bones. In the kidneys, all it does is stimulates the kidneys to reabsorb calcium, not to pee it out, okay? Not to urinate out your calcium. It tells your kidneys, just like ADH told your kidneys not to urinate out all your fluids, all your water, this hormone, PTH, tells your kidneys to hold in calcium. Like we need some of that. In your intestines, it promotes the activation of vitamin D to increase the absorption of vitamin C. So here, vitamins D and C are best friends. Okay, they go together. Okay, wherever you see one, you need to see the other one. We cannot absorb calcium unless we have vitamin D present. So if you're taking a vitamin C supplement, you need to take vitamin D at the same time. Okay, they go together. You are not absorbing enough calcium if you have low vitamin D levels. And a lot of females are low in vitamin D. So you should be taking a supplement or talk to your doctor, okay? So that's the parathyroid hormone. When your blood calcium levels get too low, this hormone is secreted, okay? So the relationship with your blood calcium levels. So if your blood calcium levels, if your blood calcium levels are low, then your PTH levels in your bloodstream are high. Okay, they're alternately related to each other. If one is low, the other is high. But then, if your blood calcium levels raise, because PTH encouraged all these places to put calcium back into the bloodstream, then that blood calcium level goes up, PTH is no longer secreted, so the level of PTH in your bloodstream goes down. They're inversely related to one another. Okay, perfect negative feedback. All right, so the next ones, and I'm going to lasso this and kind of move this out of the way because it's in my way right now. Everything's going kind of slow. Okay, and that didn't work. Okay, so I'll just keep it like it is. Okay. So next, we're going to jump right into the adrenal glands. There's two different parts to the adrenals. You have a cortex and a medulla, and that'll be the last gland for this video for number 3. So here we're talking about the adrenal glands. I don't have a letter beside it because I'm going to split them up into the two. Okay? These are just pyramid-shaped organs that sit on top of your kidneys. They almost look like a little snow cap on top of a mountain, top of your kidneys. And all of our adrenal hormones are going to help us cope with stressful situations of some kind. So there's 2 different glands in your in each adrenal. So we have an adrenal cortex And cortex always means the outer area. Okay, that's the bulk here. There's mainly the outer area. And there's just a little bit of the middle, like the juicy middle, whatever. And that is just the word for middle in Latin. That just means the middle of the adrenal medulla. And the medulla is the inner. Oh, goodness. Okay. And so here we go. I know this is getting very microscopic and looking at the different types of cells. But here we can see that the medulla is the center and the cortex is the outer area. So first we want to jump right into the cortex. So we're looking at the adrenal cortex glands. And again, there's one on top of each kidney. And this adrenal cortex is going to synthesize over about 24 hormones that are collectively called corticosteroids. So these are our steroid-based hormones. Okay? And so these are the ones that are considered, so these are steroid-based. This was in your first video. Steroid-based. So these are lipid-soluble. So these are the hormones that can get in the cell. And they're the ones that go all the way to the nucleus, bind to DNA, cause transcription. That's how they get the cell to do what they want. So there's 3 hormones, 3 main ones here, okay? And the first one is called, and they all end in corticoids, okay? Because they're all corticosteroids. So they're all in that same family. The first one is called mineral O corticoids. Just put an O there and shove those 2 words together. Mineral O corticoids. Of the mineral O corticoids, the most important is called aldosterone. Aldosterone. Okay, so we're talking about our mineral levels. Here we're targeting the kidney tubules, where in the kidneys that blood is filtered. So here, this hormone, these groups of hormones, aldosterone, is going to regulate your electrolyte concentrations and all the extracellular fluids, which is extremely crucial for homeostasis. So one, it stimulates sodium reabsorption to help increase our blood volume and blood pressure, and it causes potassium secretion into the tubules for elimination from the body. So we are absorbing sodium from our blood in the kidneys, and if we have too much potassium, we're secreting that out in our urine. So it's helping to keep sodium and potassium levels regulated. Those are our electrolytes. Okay, very important for nerve impulses, muscle contractions. Okay, the second main group of hormones, okay, here secreted by the adrenal cortex glands, is another type of corticoid, and this one is the glucocorticoids. The glucocorticoids, of which we want to talk about cortisol. So I'm just listing the main one in each little group. The so gluc means sugar, and corticoid just means the steroid hormones. Target is our blood, so it goes out into the bloodstream, doesn't have a specific cell in mind. It's going to increase energy metabolism in our cells, so it's really targeting every cell. And it helps us reduce stress by keeping enough blood glucose, keeping enough sugar in our blood, so it's keeping the blood glucose levels constant. So basically, kind of a happy hormone. Kind of like cortisol can be our stress hormone. If you get too much, too little, it causes lots of problems in the body. So you want to have a certain amount of sugar in the body to keep every cell happy so that they can go about their normal activities, normal metabolism, producing ATP for energy. So it's kind of just like a little happy hormone. Like keep all the cells happy so they don't suffer illness. And then the third hormone secreted by the adrenal cortex gland are a type of sex hormone called the gonadocorticoids. The gonadocorticoids. And sometimes you'll see it just as our adrenal sex hormones. So your adrenal glands also help with reproduction in a small way. So the gonadocorticoids, okay, most of these are weak androgens, and androgens are your male sex hormones, right? And they're converted to testosterone or to estrogen. So males and females both have this. And one of the things they help with is contributing to your axillary and pubic hair. Remember, like axillary is your armpit. Okay? So these just are secreted in small amounts, so they do help. But if you get a hyper secretion of this, that is where especially dangerous in a female, because it will make her grow facial hair and she will end up with a beard and have a lot of reproductive problems. So females do not need to have too much testosterone, and this can be converted to that in the female body. Okay, so those are 3 types of corticoids secreted by the adrenal cortex. So the last gland we're going to look at today is the middle of the adrenal, and that's the adrenal medulla, which just means the middle of the adrenal. Adrenal medulla glands. Okay. And so we're just looking at one group. So there's only one hormone secreted here, and they're collectively called the catecholamines. Catecholamines. This is your epinephrine, and norepinephrine. I'm writing really big, per usual. Norepinephrine. This targets your blood, so it goes out to all of your cells. And what this hormone does is it prolongs the fight or flight response that was triggered by your sympathetic nervous system. So the fight or flight response is a very quick, because nervous system is quick, right? You see a bear in the woods, you run, right? You don't just like try to sit there for 2 minutes and try to figure out what to do, right? It's quick. You see a spider and you're deathly afraid of spiders, you jump up and get on top of the desk or whatever. Okay? And so this hormone actually keeps that response going. Because remember, hormones have a lag period and they keep that going. And so if you were to be driving on the interstate and someone slams on their brake in front of you, and you have to slam on your brakes and you think you're about to hit them and you freak out for a second and everything's fine, you were stopped in time, but a couple minutes later, you're still kind of shaken. Your heart's still racing. Your palms are still sweaty. That is epinephrine. Epinephrine is keeping that response going so that if you needed to, you could fight, or, you could do some extreme activity because you were in danger. And so this hormone is important to keep that going. So that's epinephrine. Norepinephrine is going to bring us back to our norm. Okay? Epinephrine is our freak out hormone. It kind of gives us that fight or flight prolonged response. Okay? So that's the adrenal medulla. And that is the end of video number 3. Pike out. Bye, guys.